All right, let's take a look at an example of checking if a number is divisible by 7. Let's say you were curious, is the number 39,872 divisible by 7? Well, what this rule says is you can take whatever the last digit is and just erase it, but then take 2 times that digit and subtract that from the remaining part. What? That seems weird. So what's going on? You take the last digit, in this case is a 2, just erase it, but then take 2 times that digit. Well, 2 times 2 is 4, so subtract 4 from the remaining part. So the remaining part here is going to be 3, 9, 8, 7. Well, just subtracting 4, what do we got? Well, that's going to be 3, 9, 8. 7 minus 4 is 3. So, okay, so does 7 go into 3,983? I have no idea. So just do it again. Take the last digit, which is now 3, just erase it. 2 times 3 is 6. So now we go ahead and subtract 6 from the remaining part, which is 398 minus 6. Again, super easy here to do. In our head, we have 398 minus 6 is just going to be 392. Okay, does 7 go into 392? I have no idea. So do it again. The last digit is 2. Erase it. 2 times 2 is 4. So we take 39, the remaining part, subtract off 4, and what do we have? 39 minus 4 is going to be 35. And oh, I happen to know that yes, 7 does go into 35, so that means that yes, 7 must also go into 39,872. Okay, but wait a minute. That seems weird and mysterious. The real question is here, why? Why does this work? So here is just a place value chart. I call this a 10-to-1 machine. What is a 10-to-1 machine? Well, it's just a row of boxes. We have a rightmost box, and boxes extend off to the left as far as we desire. And all we do in this machine is we put dots always into the rightmost box, but we have a rule. And that rule is whenever there's 10 dots in a box, they explode, they go kapow, and they become 1 dot, 1 space to the left. And what we get is a code for numbers. But that code in this 10-to-1 machine is, well, it's going to be exactly how we write numbers normally. But wait a minute. We could do a 2-to-1 machine. Same exact machine, but now it is, we always put dots in the rightmost box, but now the rule is whenever there's 2 dots in a box, they explode and become 1 dot, 1 space to the left. And we can count forever in a 2-to-1 machine and get codes for numbers, or we can do a 3-to-1 machine or a 4-to-1 machine, or whatever kind of machine we like. But if we wanted to stay in a 10-to-1 machine and use our typical base 10 or decimal system, we can actually make sense of all the arithmetic we learn in school, from addition, subtraction, multiplication, yeah, but division, oh my goodness, division, exploding dots, makes division crystal clear, and you actually see that dividing polynomials is exactly the same. It is no harder at all. It is exactly the same as doing grade school arithmetic. And really, a polynomial is just a number, in a sense, in every base at the same time. But this divisibility rule for 7 and making sense and really proving divisibility rules using exploding dots, well, in the world of exploding dots, I believe that subtraction does not exist. You never have to subtract. Subtraction to me is the addition of the opposite. So if you're adding dots, well, you just add dots together. And if you have ever more than 10 dots in a box, they just explode and become 1 dot, 1 space to the left. But if you're subtracting, if you're doing, let's say, 1 minus 1, no, that's the same thing as 1 plus the opposite of 1. So if you have a dot, well, they need something to represent the opposite of a dot. I like using an open circle, and I like calling this a Todd, like the opposite of a dot. So maybe an anti-dot, but I like Todd a lot. And the thing is, if you ever have a dot and a Todd together in a box, it's like matter and antimatter. They just annihilate, and they go poof. So what this rule is saying, for divisibility by 7, to check if a number is divisible by 7, what you can do is just take the last digit and just erase it. So then what are we saying? If we're saying if the last digit is 1, if the last digit is 1, well, then we just have a 1. We have 1 dot in the ones box. Now, erasing that dot is putting in a Todd. It's putting an anti-dot in the ones box. Because a dot and a Todd, poof, they annihilate. So if the last digit is 1, we're just putting a Todd in the ones box, but then we're taking 2 times that digit and subtracting that from the remaining part. So taking 2 times that digit and subtracting that from the remaining part, well, that's putting in 2 Todds next to 1 Todd. So what we're doing is we're putting in 2 Todds next to 1 Todd. But what are we doing? What is 2 Todds next to 1 Todd? Well, that is just the anti-version of 21, right? 2 dots next to 1 dot is 21. 2 Todds next to 1 Todd is the anti-version of 21. It's like we're just subtracting 21. But wait a minute, 21 is divisible by 7. So I don't care how many times we subtract 21. In this case, the last digit was 2. So that means we had 2 dots to start out. So we're putting in 2 Todds, but then taking 2 times that digit. So now we're putting in, well, 4 Todds, right? 4 Todds next to 2 Todds, which is like 2 21s, right? That's 42, which is like 21, and then subtracting 21 twice. So subtracting 21, I don't care how many times, is not going to change if the original number was divisible by 7 or not. So there it is, a proof. I would say QED, there it is, proof, absolute proof why this weird and mysterious divisibility rule for 7 works. Calculator, take care.